So in this video, we're going to talk a little bit about monopoly, which is one of the other market structures besides perfect competition. It's actually the opposite of perfect competition. So in this one, a couple of things to observe. We only have one firm in the market, and we've already talked about some characteristics of these monopolies, but just as a quick review, they generate a unique good, so there's no other product like it, and within that geographic area, of course. So, for example, you might have an electric company within your own town or city, and that's the only electric company in town, so they have a monopoly on electricity sales. So the nice thing is the market graph is the same as the firm graph. So we only have one graph for monopoly. We're going to make some changes to it, of course, to show it in profit or loss and that kind of thing. But there is one thing that we're going to observe here. Because of a downward sloping demand curve that exists in a monopoly, the monopolist firm has to reduce the price to sell additional units. And now, in words, this says therefore, each additional unit reduces marginal revenue and drives a wedge between MR and demand. Now, that's something that sometimes students tell me they have a little bit of trouble wrapping their minds around. So to help you out, I'm going to write kind of some numbers off to the side. And where I'm going to do it is actually on the next page in the packet where there's plenty of blank space, but I'm actually going to do it kind of down here at the bottom of the page. So imagine that you had a quantity of a product and that you had a price for that product. And again, if we connected these two together, the quantity demanded with the price, you get demand, the relationship known as demand. And if we said that we had a monopolist that was selling a product, and we could imagine their demand curve for that product would look something like this, where you have quantity demanded 0, 1, 2, 3, 4, 5, 6, and the price, let's say, if the monopolist said, okay, I'm a price maker, I'm going to set the price, and they decide they're going to set it at 10, then they'd sell 0 units, right? So the monopolist is still limited by demand. And therefore, we can add another column and say, therefore, their total revenue is quantity times price is 0, right? They don't make anything. And the marginal revenue of that unit doesn't exist because it's the 0th unit. Now, if they decide, oh, I'd like to sell a product today, they'd have to lower the price. So they lower it to 9, and they sell 1 unit. So the total revenue is 9. And the change, marginal revenue, 9. So far, so good. But let's say that they profit maximize at MR equals MC, and their MC is equal to we'll say 5, or let's actually say their MC is 1. So they're going to produce the next unit, right? They're going to decide, okay, I'm going to produce another unit. In order to do that, they have to lower the price. So they lower the price to 8. 2 times 8 is 16. Now the marginal revenue is 7. Now, that at first glance, right, a little math trick, I pulled a rabbit out of a hat here, but now at quantity 2, the price is 8. They sold that second unit for 8, but they only got 7 in marginal revenue. They only got 7 in marginal revenue. How can that be? How could it be that you could sell a unit for $8 but only get 7 of additional revenue, right? That almost doesn't make any sense. Now, the way to think about it is the first one, right, the first person, they could sell it to them for 9, but when they cut the price to 8 for the second person, that means they also have to cut the price for the first person to 8. So they don't get 8 additional revenue because they lost $1 of revenue when they cut the price for the first person, right? So imagine that the two people walked into the store at the same time and they both pick up the same thing off the shelf, then they both pay 8. And if there had been a price of 9, then only one had bought it at 9. So that first person no longer pays 9, they pay 8. So the additional revenue is not 8 from the second unit, it's 7. Because we got 8 from the second person, but we gave up $1, and so now we get 7. Now, if they decide they have to keep lowering the price because marginal cost is 1, marginal revenue is 7, so they're going to keep adding units. So now they go to $7. They sell 3 units at 21 for total revenue 21. The marginal revenue got further away, got to 5. Because for this one, they had to give $2, right? When they moved from 2 to 3, the third person said, okay, plus 7 worth of revenue, right, from the third person. But from the second person, right, who we were charging 8, Now we don't charge them that, so we only charge them 7. We don't charge them 8. And the first person, we also subtract 1 because we were charging them 8 before this. Now, some students often say, but we were charging them 9. That's right. So we're comparing moving from 2 to 3. When we go from 2 to 3, the first person goes from paying 8 to 7. The second person goes from 8 to 7. So both of those cost us $1, and 7 minus 1 is 5. Then we lower the price again to 6. Total revenue, 24. Marginal revenue, 3. Again, because we gained 6 from the fourth person, right? From the fourth person, but the third, second, and first person, now we have to subtract $1 because we cut their price. So the total marginal revenue is $3 from that fourth unit. Fifth unit, 25, 1. Right? And now we could keep lowering the price and we'd find actually it goes negative. Marginal revenue starts to tick down again. Right? It starts to tick downwards. So they should produce, we know that they should produce the fifth unit because MR equals MC here, but you could imagine a TR curve that does one of those. Right? And we're going to kind of take a look at that tomorrow. The most important thing is that you have this demand curve and that now you have a marginal revenue. And if we add those quantities off to the side, we can say quantity 0, 1, 2, 3, 4, 5, 6, 7. If you can imagine, you've got this relationship of quantity and marginal revenue, and I just rewrote this column over here. And then you have this relationship, which means that marginal revenue does not equal demand for this type of a firm. So that's by way of saying this. Because of a downward sloping demand curve, the monopolist has to reduce the price to sell additional units. Each additional unit actually is going to reduce marginal revenue and drives a wedge between MR and demand. Now, they're still going to produce at MR equals MC, and an important thing is we're going to price on the demand curve. Super important. Why do we do that? Well, look back to our little table here. Demand tells us the price, right? Marginal revenue does not tell us the price, right? That's not the price. This is the price, and it's within that demand curve. So we can actually get away with saying D equals P, just like when we had Mr. DARP, we said that MR equals D equals AR equals P. So we can get away with that, but we can no longer say that it equals Mr. Right? So the Mr. is not going to be part of the DARP. The last thing we're going to say is there's 2 types of monopolies, and then we're going to do 3 graphs, and then we'll be done. Natural and artificial. So I'm going to cross that out and write artificial, because it's probably better than non-natural. Artificial monopolies have U-shaped ATC curves, and natural monopolies are ones in which throughout the range in which demand exists for the product, they are always getting increasing returns to scale. And what that means is that if you think about an electric company, the very first customer on the ATC and on the MC is going to be really high. It's going to be very expensive. But by the time they get to the 4th or 5th millionth customer for the electric company, connecting that 4th or 5th millionth customer to the grid costs very little. And they're already going to be producing those units of electricity. So connecting you, the 5 millionth customer, to the grid basically costs them very low amounts of MC. In addition, the average total cost is going to be spread out over millions and millions of people, and it won't ever start to tick back upwards again like what we saw in perfect competition. So that's what we call a natural monopoly. And it might help if we look at a graph. So here's a natural monopoly, and we're going to do it in a profit first. Price and quantity. And because it's the market, we have a downward sloping demand curve. And we said that the demand curve equals the price, right? That's where you kind of get the price from, is the other way to think about that. Now we also know that marginal revenue is going to come down faster than the demand curve, right? These two are going to have a wedge driven because of that table that we looked at a few moments ago. And at the very first unit is where they're going to connect, right? They come to make a vertex together at that very first unit. And then they spread out from there. So if you want to look back here for just a quick second, the very first unit at quantity 1, the marginal revenue is 9, the price is 9. At quantity 2, price is 8, marginal revenue is 7. So once they go to the second unit, that's where they start to diverge. But they are the same. They hit a vertex at MR and P, hit a vertex at the very first quantity. Now, earlier, when I was just talking about natural monopolies, I said that the very first customer is quite expensive. The additional cost of that very first electric company customer is quite high. But then it starts to kind of pretty much flatten out to just the cost of adding the line to their house, which is fairly minimal. So what we're going to say is that you have kind of a slight downward slope at the beginning, and then we're just going to draw a flat line. And we're going to say that's MC. And so if it looks like it's starting to tick up again, it's not. It's supposed to be a flat line. Then we're going to draw a downward sloping ATC that never gets to the MC either. Right? It never quite gets there either. And that's because the very first unit is going to be really expensive ATC, but it's always going to be lowering and lowering and lowering in which the demand exists for this product. It's always going to get lower. Now we could imagine that if this quantity axis extended out to like 5 trillion customers or some crazy number, that eventually that marginal cost would start to tick back upwards again, and MC would cross through the minimum of an ATC. But we aren't worried about those, right? We're not worried about those. If this is still really discomforting to you, right, I'm going to draw a quick picture up here at the top to show you what's really happening. We need to imagine the graph that we looked at in the previous couple of days. And we looked at a downward sloping and then come back up marginal cost. Does one of those. And ATC did one of these. Came down and then comes back up again. All right, and that's kind of what we've done. Now, if I just said, okay, the demand basically goes wee down like that, right, then I wouldn't really need this other part of the graph. So if I just covered that up, right, that's kind of what we actually have here. It looks pretty much the same because for which there is the range where demand exists for the product, ATC and MC are downward sloping. So it's kind of like that part of the range is where it exists. So let's get back to our little show here. With this one, they always are going to produce at MR equals MC. So we just find MC equals MR here. Quantity. I'm going to write QF. That's also the quantity in the market. And then it says price on the demand curve. So then we go up to the demand curve. That's the price. Okay, so then we go across, dotted line, price that the firm charges. And then, since it is a profit, price is greater than ATC at QF. That's when we draw our rectangle by comparing the price to the ATC, which is here. So we're going to put a dot, and then we connect those two, and that's the profit per unit. And if we go over and over and shade this area, that's the profit rectangle. So we compare price to ATC at the quantity F, and we shade over, and that's the profit rectangle. And that's all it is for natural in profit. Now we're going to draw natural in loss, and we'll see it looks really similar. We're going to see it looks really similar. So we'll say a downward sloping demand curve that's equal to the price, right? That's the price we charge. And then marginal revenue. And just to simplify it, I'm just going to draw a straight line across for MC, because it's not actually important that you have that MC. And even sometimes they'll actually say MC equals the ATC, and they'll just make it all a flat line. But we'll draw it kind of correctly here. Now, if we know that the firm is producing where MR equals MC, so that's there. That's where those cross. Quantity down. And then they price on the demand curve. So go all the way up to the demand curve. That's where they price. Okay, price the firm charges. But it tells us they're in a loss. So price is going to be less than ATC at QF. So our ATC is going to look like that ATC. It's going to be that downward sloping line. But at QF, it needs to be above the price. So it's got to be like somewhere up here. So we're just going to draw a line coming down, just like that, ATC. And we find that at QF, the ATC value is way up here. And if we connect those two dots that we just finished drawing, those two, that's the loss per unit. If we go across, this area is the loss rectangle. The loss rectangle. Because again, we're comparing price to the ATC, at the profit maximizing quantity. And in this case, it's the loss minimizing. Now we're going to do the last one. And again, these look really similar. If you kind of observe, the ATC is just moving, is what we're really doing here. We're just moving the ATC. Natural in a normal or break even. This is sometimes called a fair return. It's a fair return because they're earning accounting profit even if they're breaking even in an economic sense. Demand equals the price. Marginal revenue. Marginal cost. And they produce at the quantity where MR equals MC. And then we price up here on the demand curve. Price the firm charges. But this one, natural in normal, means price equals the ATC at QF. So if we continued that line up here and down here, that means our ATC line that comes down is going to have to equal that point. Right? It's going to have to come down, cross through that point, and then come back up again, just like that. Now we're not going to draw a profit or loss rectangle. Why? Well, because we're breaking even. There isn't a profit or a loss. There isn't a profit or a loss. Now, one observation that I like to make here with students is that with monopolies, because the barriers to entry and exit are so prohibitive, even if they're earning a profit in the long run, like this firm, firms aren't going to enter. They can't. It's a monopoly. Even if they're earning a loss, the firms can't really exit. Now, in real world, oftentimes governments will subsidize monopolies that they believe are important to the public service, and they'll subsidize them. And if they're earning a normal profit, that's just a coincidence. It doesn't necessarily mean this is the long-run equilibrium, because all three of these, the profit, the loss, and the normal, are all long-run equilibria in monopolies. So hopefully this helps you understand a little bit of the ideas behind monopolies, and in the next couple of videos we're going to take a look at artificial monopolies. I'll see you next time.